Hello, good day. Welcome to Math with Isaiah, and today I have one of my most exciting topic, which is circuit geometry. I actually know how much of phobia people have for circuit geometry, so my job this afternoon is to simplify it in the best way possible. Now, how do I explain this? You all know what a circle is. So what my job will be to explain what geometry really means. So let me help you out. So the Greek word is actually coined out from two Greek words, geo and then metron. So geo basically means land. So if you say geopolitical, meaning politicality in a particular sphere or on the earth and all of that. Now metron speaks about measurement. So basically geometry just means measuring the earth or measuring a land in accurate precision and all of that. So now take that measuring capacity into a circle, the build up of a circle. So that's basically what circular geometry is. We're trying to measure the diameters in a circle, the circumference, the chord, the sectors, the segments. That's basically what circular geometry is all about. But then we have about 8 theorems. About 8 theorems under circular geometry. But in this video, I will be talking about 2 theorems. Now, this is the first theorem. Now, the theorem states that a straight line drawn from the center of a circle to bisect a chord is at right angle to the chord. Now, note what I said. Number 1 is a straight line. Number 2 is drawn from the center of the circle. Number 3 is bisect. Emphasis on the word bisect. Bisect is not the same as divide. If I have this straight line now, I've divided it this way. But when I say bisect, it means to divide into 2 equal parts. So it means something like this. Dividing, so we have 2 equal parts. So that's the word used here, bisect. So a straight line drawn from the center of a circle to bisect a chord. A chord is at right angle to that chord that was bisected. Now let's draft it out now. So we have a circle here. But this is a circle. This is the center of the circle. Now, what is a chord? Now, the only difference between a chord and a diameter. I know many of us knows what a diameter is. A diameter is simply a straight line touching 2 points on the circumference of a circle. This is the circumference of a circle. So touching 2 points on the circumference of a circle and then going through the center of the circle. That is what we call a diameter. So this is a diameter. A straight line touches 2 points and then goes through the center of the circle. That's the diameter. Now the difference between the diameter and the chord is that diameters go through the center, chords don't. So this is a chord, this is a chord, this is a chord. As long as it doesn't go through the center, then it's not a chord. I hope you get. Now, what we're dealing with here is a chord, not a diameter. So I'm going to cancel this. Now, very quickly, we have a circle, the center, and now we have a chord. Let's put it here. Now, the theorem states that a straight line drawn from the center of the circle to bisect a chord, meaning it divided the chord into 2 equal parts, is at right angle to the chord. What that simply means is that the angle formed between the straight line drawn and the chord is a right angle. That's basically what it means. Now, if you look at this, now let me quickly explain the little part in a circle. I said the diameter goes through the center, right? A straight line touching 2 points on the circumference of a circle and goes through the center of the circle is a diameter. Now, a radius basically means you're dividing the diameter by 2. So if you have this as a diameter, then you'll be having this as a radius. So that's basically what it means. So a radius is any line drawn from the center of the circle to touch any point on the circumference of a circle. So if you drag it like this, like this, like this, like this, you have the radius. I don't want to, taint the screen. Now, if we drag this like this and we drag this here, this is a radius. This is a radius. this is a chord. Let's write chord. So this is what the theorem states. The theorem states that a straight line drawn from the center of the circle to bisect a chord is at right angle to the chord. Now, take for instance, okay, I'm not going to explain that. But whenever you're given a theorem like this, what that simply means is most of the time you have to solve using Pythagoras theorem. I might make a video for that subsequently, but for instance, you're given the chord to be, let's do 20 centimeters, and then you're given the radius to be, let's say 13 centimeters. Now, they now tell you find the length of the straight line, meaning find the length of this, let's call it h. Now, how will you solve something like this? You can bring out one of this triangle, which will be something like this. Then you have here to be 13 centimeter. You have here. Now, because it was divided, emphasis, bisect, that means if the whole chord was 20 centimeters, that means from here down here will be 10 centimeters. From here down here will be 10 centimeters. So that means here will be 10 centimeters. Now we have to find here. We know here to be a right angle. Pythagoras theorem, I might make a video about that later, but states that 13 squared is 10 squared. Plus h squared. That simply means 169 equals 100 plus h. So that means plus h squared. So that means h squared equals the 69. So h is the square root of 69. That will give you decimal and all of that. But I just quickly made this rough example to explain what I'm trying to emphasize. So this is the first theorem. A straight line drawn from the center of the circle to bisect a chord is at right angle to the chord. So that's the first theorem. So this is the second theorem. It's very simple. Now I'm not arranging the theorems in a, what I call a sequential order. No, I'm not following any format. So this is the second theorem. Now it simply states that angle in a semicircle, some people call it semicircle, I don't really care. When I was in secondary school, there was a lecturer, one of our facilitators, I used to call the word determine. He calls it determine. I don't know the difference, and I don't really care, as long as you get what I'm trying to say. Anyways, so angle in a semicircle is 90 degrees. Very quickly, this is a semicircle. I'm sure you know what a semicircle is. A semicircle is just half of a circle. So a full circle divided into a bisected circle, if there's a way to put it that way. Yeah, so a bisected circle is a semicircle, half of a circle. Now, this is a straight line. You would agree with me that this is the center of the circle and this is the diameter. Like I said at the beginning of the video, the diameter is a straight line touching 2 points on the circumference of a circle and going through the center of the circle. So if this circle was divided at the center, that means this. If it was divided into equal halves, that means this was the center of the circle. Now, so this point of diameter, if it subtends any angle, something like this, meaning these 2 points of diameter, if they subtend any angle, it will turn out to be 90 degrees. Any angle that is subtend, if they subtend the angle like this, if they subtend it like this, subtend it like this, they will all be 90 degrees. So that's basically what this second theorem is talking about. Now when you have all these theorems in your head, then you will be able to attend to questions. But my job basically in this video is to outline the theorems. So like I said, angle in a semicircle is 90 degrees. If you come across a question in your exam, for instance, and you see a semicircle like this, and they draw something like this, and they tell you this is the center of the circle, this is A, this is B, this is C, and this is center O. And they tell you, let's say here is 60 degrees. Then they tell you find angle A, B, C. When they say angle A, B, C, the emphasis is this angle that's here, A, B, C. So that means this angle. So when it says find something like this, you already know that this is a semicircle, automatically this is a right angle which is 90 degrees. Sum of angles in a triangle is 180 degrees. I don't know, I've always been someone that likes emphasizing solving with your head, not necessarily writing all the time. That's why I'm not really writing. So sum of angles in a triangle, this is a scaling triangle though, but still a triangle nonetheless. So sum of angles in a triangle is 180 degrees. So if you have 60 here, you have 90 here, that's a total of 150. How many degrees will this be to make it 180? That's 30 degrees. So automatically this is 30 degrees. You solve this question without using a pen. So that's basically how you use this theorem in solving questions. There are times when you have to use like 3 theorems in one question, but we'll get to that. So this is the second theorem, and this is how to use it. Angle in a semicircle is 90 degrees. So in the next video I will be talking about the other theorems.